Ready for study? Hello bachcho, welcome to our channel Feel the Chemistry.
So hello students, today we will discuss about the new topic, that is rules for stability order of resonating structures. Yesterday I got a message from one student and he texted me that there are some issues on the topic resonating structures, stability order of the resonating structure. So today we discuss about this topic. There are a few rules to check the stability order of the resonating structures. So they are written over there. That is, first look for more covalent bonds. So first we're taking an example. So give the example, that is CH2 double bond N. Okay. Then next one is CH2 single bond N double bond N. Third one is CH2 single bond N triple bond N, and the fourth one is CH2 single bond N double bond N. So the first point, that is, first look for more covalent bonds. The question we get our questions. So firstly check the number of covalent bond in the compound or a molecule. In this, when we count the covalent bonds, there is 1, 2, 3, 4. Okay, and in this 1, 2, 3, 4. So in this two options, their number of covalent bonds is 4. Okay, and in second and fourth, CH2 single bond and double bond, and there are 3 covalent bonds, and in the fourth there are 3 covalent bonds. So when we find the stability order, so that is, first we check about covalent bonds. So in first and third, there are number of covalent bonds are 4, and in this 2 and 4 there are number of covalent bonds are 3. So more covalent bonds are more stable than the others. Okay, so in this two there are 4 covalent bonds, so these two are more stable than these two. Okay, now we will compare and we compete these two options. So now we check the second point, that then for neutral structures over charged ion. So in these two options there are no any neutral charges. If in between these two, if anyone have neutral charge, then the stability is more. Okay, first we check the number of covalent bonds. If any one of the options have more covalent bonds, then the stability is more of that particular option. Okay, and then second we check the neutral charge. If anyone in the option, anyone have more anyone have neutral compound, so we prefer that compound more stable than others. Okay, but between these two there are no neutral species, so we check the charge on the atoms. If the nitrogen have positive charge, because we know that nitrogen is more electronegative than carbon. If nitrogen have a positive charge on it, so that one is less stable. Okay, and we know that carbon is less electronegative than nitrogen, and if carbon have um, negative charge on it, so it is unstable, because we know that nitrogen is more electronegative than carbon. So whenever the less electronegative atom have negative charge on it, so it is unstable. So in these 4 options, the most stable compound is this. Okay, because in that option, one nitrogen have negative charge and one nitrogen have positive charge. There's in that carbon atom there's no any charge. Okay, so the first option is more stable. Then the second, then the third option, that is nitrogen have positive charge, that is unstable. Okay, and the carbon has negative charge, and already I told you that whenever the carbon or a less electronegative atom have a negative charge, it is unstable. Okay, so the stability of order of these 4 is first one is A, and then 3, 1, 3, and then we check about in these 4, because these two are same covalent bonds, and in this option you can see that the carbon have negative charge. Okay, and I already told you that whenever less electronegative atom have negative charge, it is unstable. So the least stable compound is fourth. So the stability order is 1 is most stable, and then 3, then second, and then fourth. Okay, and I already written over there that first count number of covalent bonds. So in first and third there are 4 covalent bonds, so these are more stable than 2 and 4. I already mentioned over there. So now compare which is more stable in 1 and 3, as I already told you. Then we compare between these twos. Okay, 1 and 3. In first, the negative charge is on the more electronegative atom. Okay, and in 3, negative sign is on less electronegative atom. So one compound is, first compound is more stable than other. Okay, the last stability order is, final stability order is 1 is more stable than 3, and 3 is more stable than 2, and 2 is more stable than 4. So fourth is the least stable compound. Okay, now we check, and now we take a second question. Before that, read all the stability rules. We already covered this point, that firstly count number of covalent bonds, then check the neutral species. Okay, in the options, if anyone have number of covalent bonds, like all options have number of covalent bonds are 4 4 4, and something have 5 5 5 5. Okay, but in that one have a neutral species, number of covalent bonds is differ, not differ, sorry. Okay, number of covalent bonds are same, but one is neutral species, so we prefer that one more other than others. Okay, next, third point is for the fewest number of formats. Okay, so this means that we check firstly if anyone have one charge and other have 2 or 3, so we give the priority to the fewest charge atom, okay, or a molecule. Then fourth one is placement of negative charge on more electronegative atom and positive charge on less electronegative. We will already covered in this example. Okay, and the fifth one is structure with greater charge separation. Okay, we will discuss this point at the end. Okay, when we take an example, then we definitely cover this rule also. So we take an second example. In this there are number of firstly we count the number of covalent bonds. There are 1 2 3 4. Okay, and in this there are 3, and third one also have 3. So the more stable compound is first, because the number of covalent bonds is more than these two. Okay, there are 4, there are 3, and there are 3, so 4 is more stable. Okay, so we give the priority to this molecule. Then in this option we check carbon is less electronegative than oxygen. So I've already told you that when the less electronegative atom have a positive charge or more electronegative atom have negative charge, then it is more stable than this species. Then carbon have, because in this species carbon is less stable than oxygen but carries a negative charge, so it is unstable because it is less electronegative than oxygen. So we give the least priority to this molecule. So the stability order is we give the first priority to this compound because the number of covalent bonds are more than other two. Okay, and in this second, the negative charge is on the more electronegative species, so this is more stable than third one. Okay, same we check in this example. There are number of covalent bonds are 1 2 3 4 5 5, and 1 2 3 4 5 5 1 2 3 4. There are 4. In these two there are 5 covalent bonds, and in this one there are number of covalent bonds are 4, and 1 2 3 4 there are also number of covalent bonds are 4. So first we give the priority to these two compounds because they have number of covalent bonds are 5. Okay, and now we compare between these two, that which one is more stable. So we check that in this option, this is the neutral species, there's no charge carries on it. Okay, and in this oxygen and oxygen carries a charge, so this is more stable, because I've already told you in the second rule, more neutral species are more stable. Okay, so firstly we give the priority to this one, then second this, and now we check in these two, because they are number of covalent bond 4 and 4. Okay, if we compare these two, oxygen is more electronegative than carbon, but it carries a positive charge, that is unstable. Okay, so we will give these option the least stability order. Okay, so the result is more stable is one, and then second, then third, then fourth. I think you understand the concept whatever I explaining. Okay, so the last example for this topic is CH2 double bond CH single bond NH2 and CH2 single bond CH single bond NH2, CH2 single bond CH double bond NH2. Okay, now firstly we check the number of covalent bonds. So there are 1 2 3. Okay, there are 3, there are 2, there are 3. Okay, so second one have less number of covalent bonds than other two. Okay, so now we compare between these two, because they have more covalent bonds, okay, than 2. So in first, as we can see that there is no charge carries on this molecule, but in this they carries a charge. So neutral species is more stable than the charge carries molecule, so we give the priority to this. Okay, this is more stable, and then third one. Okay, and the last stable compound is, this is the least stable. Okay, why? Because firstly we compare the covalent bonds, so 1 and 3 have more covalent bonds than 2. Okay, so this is the least stable, and then second, first and third, we check the second rule, that is neutral species. Okay, so first is the neutral species, this is the most stable compound. Okay, then third one. Okay, and then second. And this is the IIT question. I think it is asked in 2007, I'm not sure, but in this question there's two options: CH2 single bond CH double bond NH3 and CH2 double bond CH single bond NH3. In these two cases, if you check that the number of covalent bonds are equal, okay, and only one atom carries a charge. Carbon is less electronegative than nitrogen, carries a positive charge. This is okay, this is stable. Okay, but in this case nitrogen is more electronegative than the carbon and carries a positive charge. We have already discussed, whenever the more electronegative atom carries a positive charge, or less electronegative atom carries a negative charge, that is unstable species, and will give them the least stable molecule. Nitrogen can never be pentavalent, because if you check in this option, okay, nitrogen forms a pentavalent, and this can never be, nitrogen can never be a pentavalent, so this option is not exist. Okay, this molecule does not exist, because nitrogen can never be a pentavalent. Okay, so whenever question will come in your exams, okay, so you have also checked the valency of the nitrogen and the carbon or any other atoms. Okay, now we talk about the last rule, that is structure with the greater charge separation are less stable, especially of a like charges. So we take one example, then understand this rule. Okay, so we take an example in case of two charged species of a same atom, like you can see that we take example of a same atoms AAA and AAA. So in this case, two equal charges are next to each other, and whenever the equal positive charges are next to each other, they will be unstable. Means if you can see, these two same atoms have same charges, so these species are unstable. But whenever two unlike charges like positive and negative are close to each other, they are stable. They form stable compounds. Okay, this is the last rule. And for the aromatic, we will discuss in next video. Okay, for the aromatic cases, that in the questions there are few question arises to related to the aromatic, non-aromatic and anti-aromatic compounds. Okay, so we will discuss about these topics in the next video. Okay, because we know that aromatic is more stable than non-aromatic, and non-aromatic is more stable than anti-aromatic. So there are few other rules for these three. We will discuss about this in the next video. Okay, if you understand this concept, okay, so please subscribe to our channel and share this video to your classmates. Okay, and before ending this video, we will check one example. In this case, first we check the number of covalent bonds. Okay, there are 1 2 3 4 5 6 7 8. Okay, there are 8 covalent bonds, and in this also 2 3 4 5 6 7 8, and in this 1 2 3 4 5 6 7 8, and in this also there are 8. Okay, and then we check the neutral species. There are no any neutral species. Okay, so we jump to the third rule. Okay, so we check the electronegativity, means we check the charge on the atom. Nitrogen is less electronegative than oxygen, so it carries a positive charge. It is unstable. Okay, why it is unstable? Because nitrogen and next to nitrogen it is carbon, both have like charges. Okay, both carries a positive charge, and we already discussed that whenever two atoms just next to each other carries a positive charge, they are unstable than others. Okay, that is why first option is unstable. And in this case, if you can see that nitrogen is less electronegative than oxygen, it carries a positive charge, it is stable. Okay, also in this case, nitrogen is less electronegative than oxygen, it carries a positive charge. And by this rule, you can also see that it is unlike charges. It is negative and it is positive. It is negative, it is positive. So unlike charges, whenever the unlike charges are close to each other or next to each other, they are stable than like charges. Okay, I think you understand the concept, and please ignore my fluency in English because I'm not too fluent, but I'm trying to connect with you and explain you all the concept briefly and perfectly. Okay, because my yesterday student whom texted me about this concept to explain this, it's from another country, that's why just I made this video in English. But I tried, definitely I made one more video on the same topic in Hindi. Okay, so thanks for watching my videos. Please subscribe to my channel if you understand my concept. Okay, and share this video to your classmates. Thank you.